Good morning, everyone. I'm Christina Gage, the Dean of Applied Research at Mohawk College, and on behalf of the Additive Manufacturing Innovation Center at Mohawk, it's my pleasure to welcome you to 3D in Action. I would like to begin by acknowledging that Mohawk College is situated on the traditional territory of the Haudenosaunee and Anishinaabeg Nations, within the lands protected by the Dish with One Spoon Wampum Agreement, and is currently home to many Indigenous peoples from across Turtle Island. While this year's conference is taking place virtually instead of on campus in Hamilton, I hope that this online format will nonetheless inspire you to explore the potential of additive manufacturing for your company and take advantage of this unique opportunity to connect and collaborate with your colleagues from across the country. I would like to invite Allison Horton, Vice President Academic at Mohawk College, to say a few words of welcome. Allison?
Thanks, Christina, and good morning, everyone. On behalf of Mohawk and our Additive Manufacturing Innovation Center team, I'd like to welcome you to the 2022 edition of 3D in Action. At this stage of the COVID crisis, I'm hopeful that the next time we gather, I can greet many of you in person. We would love to host you for a tour of our award-winning facilities and the innovative space at AMIC. I recognize that you're joining us from across the country, but consider this as a standing invitation for you to join us when conditions allow and the timing is convenient for you. The past year has been a promising one for additive manufacturing in Canada. Companies across the country have been turning to additive manufacturing technology to streamline processes, increase efficiency, and gain a competitive advantage in the marketplace. There have also been a number of significant funding announcements in the sector as governments recognize and support the important role that this technology has to play in our economic recovery. At Mohawk, AMIC was pleased to receive $900,000 from NSERC in the last year to support the team's applied research efforts. Projects are underway with a number of significant industry partners as a result. And this field is becoming increasingly important to a growing number of small and medium-sized businesses, making the topics and conversations you have during today's conference as important as ever. Today, you'll be hearing from a number of dynamic speakers who've been pushing the boundaries of what is possible with 3D printing. I'd like to welcome and thank our speakers for the day. They include Henry Jo, Billy Rideout, Alyssa Ross, Gerd Grau, Jillian Sheldon, Juan Schneider, Khalid Mustafa, Mitch Deborah, Nick Persikili, Steph Sharp, Yevgeny Briff, Curtis Pastorius, Sadie Muqtadir, as well as IdeaWorks team members, Sharif Abdu, Christina Gage, Justin Valenti, and Jeff McIsaac. We appreciate that everyone made their time and in their demanding schedules to address us for 3D in Action today. I'd also like to recognize that the speeches, the presentations, and sessions you enjoy today would not be possible without the support of many partners from the Canadian additive manufacturing community. We're grateful to Tsunami and FedDev Ontario for their financial support of 3D in Action. We also appreciate the assistance of NSERC. Their support made it possible to offer free registration for all of you to attend 3D in Action this week. A number of organizations helped our team plan and promote the conference as well. Tsunami, Canadian Manufacturers and Exporters, Engine, and the Trillium Network for Advanced Manufacturing. There's also a number of familiar faces on the participant list today. For Mohawk, some of you have partnered with AMIC on applied research projects in the past. I'd like to recognize the important role you've played in supporting our college and more specifically AMIC, and in contributing to the education and development of our students. It's through these partnerships and collaborations that additive manufacturing can continue to grow and succeed in Canada. I hope you enjoy the virtual 3D in Action experience and that you find inspiring and practical information in today's session to support you in your important work. Thanks.
Thank you, Allison. And now it's my pleasure to introduce our keynote speaker, Billy Rideout. Billy is the Chief Executive Officer at Calgary-based Exergy Solutions, Inc. Billy has passion for driving technology improvement to the energy industry and other sectors critical to our economy, including incorporating advancements in additive manufacturing. Please give him a warm 3D in action welcome. Billy?
Thank you, Christina. I appreciate the introduction, and really excited to present here to this audience. I'm originally from New Brunswick, and living in Alberta for over 20 years with my wife and family. And I have a big love for Canada and a big love for change and technology. So this is like the perfect venue for me to talk to other Canadians from the East. I'm gonna share my screen here because there's lots to show and lots to talk about. My topic is about manufacturing a sustainable energy future. So this is something that the team at Exergy is really passionate about, and not just Exergy, but the whole province of Alberta and Western Canada that is very committed to change in the industry. I don't know if many have heard about recently. There's a pathways to net zero, so looking at how to transform the energy sector into a net zero proposition, and it seems impossible at first. But when you look at a lot of the things that are going on right now, there's hope for what can happen, how change can be affected. I'm just going to go to the next slide. So one of the reasons I feel there's really a bright future is we really have a new, and it's multifaceted. It's about people, it's about equipment, and it's about culture. And there is a bright future because we have a really new generation of very collaborative workers. So millennials and Gen Z, they're really, they think differently. You know, they've, with Instagram and things like that, they've habituated collaboration and sharing of information. Also, they're super proficient with these new tools. You know, I imagine a lot of the students at Mohawk and other polytechnics and universities across Canada have, you know, I didn't grow up with 3D printers and all these neat gadgets at my disposal. So they really have an advantage, a strategic advantage to bring change to the world faster. And the other part is around mindsets. And this is where I really feel that the stars are aligning here, where, you know, the days where corporations were very close-minded and 100% say profit-driven, the new world and the investment world, the investment community is looking for ESG, and they're looking for environmental and social governance. They're looking for more responsible companies that actually do things in a more responsible manner, and that pressure is great. It aligns. You know, it really aligns the stars and makes a situation for change. I want to start with a bit of a safety moment because this is something that we do at every meeting. And you know, coming out of the pandemic, I think a lot of people are kind of wondering about the future. We hear a lot about inflation. You know, I'm sure the next generation is a little worried about being able to buy their first home or first apartment, and you know, things are promising in Canada and across the whole nation, really. But we need to kind of look at ourselves, and this is called ikigai, which is kind of has a weird name, but it's a Japanese concept meaning a reason for being, and it's about pursuing your passion. And what you do is you look at the intersection of what the world needs, what you love, what you're good at, and what you can be paid for, because of course everybody needs a job at the end of the day. And I would encourage a lot of the people entering the job market and looking at careers to really look for companies. There's a lot of great companies on this call that are impacting this change. So try to, you know, to stay motivated, to stay happy. This is a bit of a pursuit of happiness kind of formula here that I'm sharing with everyone. Look at companies that are working on what the world needs. Look at doing what you love and what you're good at. And you know, getting paid is just kind of a side benefit, but it's pretty important. I just wanted to, you know, kind of carrying over on this conversation is more of on a personal note. Here's me and my wife, Vicky. We met originally in New Brunswick, and we love to travel. Here's a picture of me at Vimy Ridge. My daughters tease me a lot. They say, "Dad, you and your selfies." I'm just trying to keep up with the times, but I get teased. Apparently, if you're above 40, you're not supposed to take selfies. I'm not really sure what the rule is there, but uh, and then here's in the morning here. I was running. I went for a run this morning, and we got a lot of snow in Calgary in mid-April here, and well, getting to late April. And I'm in front of this. We're really fortunate to be in this community, which used to be a base, a military base in Calgary. And I get to walk through all of these beautiful places. And this is this is called the Officers Garden. And I feel like we're so fortunate. Sometimes we think we've been dealt a bad hand, but when you look at what past generations have gone through and what's happening in the Ukraine right now, like we have a lot. You should count our blessings because we have a lot of things to be grateful for, and we should really look at. There's a lot of noise in the world, on social media. There's a lot of things, and look at the facts and look how you can actually um, play a role in changing the future. Part of manufacturing a sustainable energy future is really about people, and the generational advantage that I was talking about is what's really amazing is how technologically proficient people are, how they're collaborative, they're motivated, multitasking, um, caring about the bigger picture, which is very, very important. And we have a lot of young workers in the company, and it's just inspiring to watch them every day when we walk the shop floor and we see what they're doing. It's kind of really putting them in a position to make change in the world. So they also value feedback, and mentorship is so important. We need to have people that have experience to be working with them and mentoring them. It's very important to impart that knowledge. And sometimes we look at the next generation and we said, oh, they want everything to be green, they want everything to be this, and we can't change that fast. And this energy transition will be difficult. And you know, you want to be picky, you want to not compromise your standards, and you want to set high standards, but you also want to kind of tie in with reality and try to help the energy industry in its current state in this transformation. This is one thing that we're particularly proud at Exergy is really helping companies make that change. A little bit about collaboration. What I find exciting is there's so many new energy technologies out there right now. We've been working on things from fuel cells to energy storage, hydrogen, renewables, and like the amount of startups, like especially in Western Canada, but I'm sure there's many out east as well, is just amazing. But in order to really impact change, we have to look at these large industry players and these large emitters and bring these technologies to bear with them and bring them to commercialization because they need technologies that can be commercialized at scale. And more than ever, there's a very strong desire to optimize what you see here on the right hand side. And there's a big appetite for decarbonization right now and the value chain optimization, which is like, for example, turning bitumen into carbon fiber for manufacturing. So there's also a need for efficiency. If we can look at their current operations and reduce their greenhouse gas emissions, this is really a step change that these industries need. There's aggressive targets around this pathways to net zero between 2030 and another set of targets down to 2050. So they need help they need technological help, and they need this new generation of workers to help them with this change. Now here's some blasts from the past here. So here's Alberta bituminous sand, right? And this looks like innovation to them that they made pavement from the oil sands. And back in the day, it was very much a pioneering spirit in Alberta and across parts of Canada that were actually helping Alberta build the oil sands back in the 60s. And there's a lot of excitement behind it. And then if I look on the present, here's just a picture of a 3D printed nuclear reactor. So, we talk about net zero, we talk about small modular nuclear reactors and potential applications of these in the oil sands to drastically reduce the carbon footprint of the oil sands. But this innovation of nuclear reactors at small scale and making them cost effective and breaking down the regulatory framework to allow innovation to move faster is going to take a lot of effort. It's going to take a lot of commitment. It's going to take um, work between government and industry and innovators to drive this change. But you can just see, and this is only in the course of 50, 60 years, what can happen, the potential. So, talking about these new tools, new rules, and this is a saying that we have at Exergy, is really taking these new tools and putting them in the hands of the next generation. You can see here the Caliber 3 printer that we just purchased with support from Suncor Energy and Engen, and it's an open source machine. So by nature, this company is more collaborative. This is a company out of the UK, and we're also collaborating with a company out of Sweden on putting different advanced materials in this machine. And it's the first of its kind electron beam machine that actually, helium positive charges the surface to not, so we don't have to pre-sinter this. So it allows this all these advantages of additive manufacturing, where you can have freedom of geometry, then you have freedom of materials. So when you combine the two of those, it really opens up a lot of possibilities. And the reason we got in with this company is that we felt that they were collaborative in nature and there was a great cultural fit. And the fact that they wanted to look at an open platform. So we're very excited to see what we can do with this device. And, really, I like to say that this is, accessible to others here. If there's people on this call that see that, hey, I think I could make a change, make a difference, and I wouldn't mind printing something on this machine, let's have a conversation, because this is a, I have a saying, we went to a 3D printing conference back in Detroit with a few of our coworkers, and I said, hey, every 3D printer in this room is yours. We don't have to purchase it. It's accessible. We have to send a file and we're going to print anywhere in the world. So I really feel that additive manufacturing brings this societal change that is required. Here's another I'll talk a little bit more about advanced materials, and not just advanced materials, but how the cost of materials is going down over time and how our ability to look at renewables is changing day by day. So just I think yesterday or today, ATCO and Microsoft announced a partnership around a solar farm. Alberta is quite sunny, even though we had snow today. The sun is shining right now, actually. There's huge potential for solar energy, and they're looking at up to 1,000 megawatts over a period of time. That's a pretty big number. Now, if you look back 10 years ago, the cost of a solar module was sky high, and now it's way lower. And you can see how adoption, as long as it's commercially viable, there's a serious need for adoption. Here's a kind of more futuristic look. In the Alberta oil sands, there's a lot of carbon, and as you extract the oil and the jet fuel and all the things that we need for living our day-to-day lives, there's a potential for byproducts, and there's a potential for lightweighting of things and making things stronger. And if you make things stronger and lighter, you also make them more fuel efficient. So this is, maybe I don't know, in my lifetime, if I'll have a personal aircraft. I don't think the wings are complete on this aircraft, so it worries me a bit. I'm just showing the shell here, but it shows how the future is bright because of, in this case, it's a case of byproducts and co-production. As you're making oil, you're also making carbon for manufacturing. And I know there's a couple companies on the call here that are playing in this space of carbon and manufacturing, and this is a potentially an exciting opportunity for Western Canada and Eastern Canada to collaborate and create better outcomes for Canadians. I'm going to talk a little bit about workforce diversity and the importance of this. So there's a serious need for cultural change in organizations. There's a serious need. You can see here in the past, there's a switchboard and predominantly women running this. I think it's probably 100% if I calculate. And in the present, we're really working on getting women into engineering, into technical professions. And I know it's not easy for them. it's a male. It has been a male-dominated industry, and there are challenges. But I want to encourage everybody to, well, encourage women to get into engineering and get into technical disciplines, and really start to bring the diversity that this transformational workforce needs, because diversity is so important to a transformation and the different cultural point of views. And it's more than gender. It's a broader base of demographics and backgrounds that are super important to create a diverse and a very high, I would call it like a hyper creative workforce. And and we see teams that are more diverse and we see them perform better. And I think that management and leadership needs to recognize this and really address it and move forward to create this diverse workforce. I, there are a fair bit of people here from the college on the call, and students, and it's important to kind of talk. I want to talk a little bit about career choices, because we really love working with universities and polytechnics, and sometimes people are looking for this master's or PhD, and there's an importance there. There's also an importance to look at other avenues and career choices. So my particular career choice have been 22 years or more, actually, 24 years. So it's going fast in the energy sector, and I've learned a ton. There's engineering and EPC companies that actually build these commercial applications, construction, fabrication, clean tech startups, which were many of the customers that we have right now. But I would encourage manufacturing. I would encourage like being good on the tools, and I'm sure at Mohawk that a lot of the students are really practical and hands-on. Um, Also learn how to integrate entrepreneurism, software, artificial intelligence, machine learning, and then visual digital technologies. And these are. It's imperative that we pick careers that, back to the safety moment, that make you happy. If if you don't think you're going to want to be at a desk, don't you know you got to be cautious, because you might end up at a desk. And what I'm really proud about at Exergy is that we've created this environment where people kind of half at the desk and half in the shop, and I think that's important to creativity, and it's important to creating change. Another message to the students is to keep learning and keep growing, participate in clubs, technical teams. To me, get diverse experiences. If you're in your comfort zone, you're in a danger zone. You're not learning if you're playing in your comfort zone. Um, while you're young, there's a science where your brain is still a sponge, you're still absorbing, and as you get older, it's tougher to learn, it's tougher to grow and change. So, get into that danger zone from time to time, and there's something to learn there. And what it helps with is that as you build your collaborative network of people with complementary skills, you understand their coding that they're coding. You understand this, and you understand how their knowledge integrates with your knowledge. And the energy transition, what's really key is how we look at systems, and how we tie it all together. That's a very important aspect of transformation, is digitization and integration of systems to really roll out true solutions to the industry, integrated solutions, because the information that's transferred between all these different systems, be it power transmission lines, generation companies, the use at your home, like try to modernize your home around automation if you can. I know my house is Googled. My wife would say that maybe a bit much, but uh, I would say that the, the digitization plays a very important role in the reduction of greenhouse gases. If you read up on it, you'd be surprised how integrating this is going to play a big role. Really seek and embrace mentorship. So there might be the old person in the room that just, you think they're grumpy and they're talking about old, historical things. They've been there and they've seen it, and they're there to help you prevent the mistakes that you might do. They and and that generation really, really wants to mentor people. I've met a lot of energy executives, and they're like, some of them are retired or semi-retired, and they want to mentor youth. They feel like it. They really see a lot of fulfillment in that. Understand yourself and work on your EQ. And EQ, when you're an engineer or a technician, sometimes we're a bit head down and we're working on our solution or our problem, and really try to understand yourself, try to understand how other people view you and vice versa, and try to build highly productive teams. So this is where I stress, like, if you look at agility, when you look at what you see is that people have these things called retrospectives, which is almost like a check-in after a sprint. And you kind of look and you talk to each other and say, how are we doing as a team? What's working, what's not. And sometimes we're just so infatuated with the technology that we're working on, is we're not looking at the relationships that we have with our coworkers. So this is an important thing, and if we can unlock this, the results and the agility of teams can be much higher, and really people could feel much more productive. And kind of finally, if you're not fulfilled or you're not learning, make a change. Don't complain about it. Look around, look at opportunities, look at people that inspire you, and try to find a way to work alongside them. So yeah, the best way you can predict your future is to create it. So thank you so much for the opportunity to present here today. I really hope that this conference is off to a great start, and that I'm looking forward to chiming in on some of the other speakers over the course of the day. So thank you, Mohawk College, and looking forward to collaborating with all of you in the future.
Thank you very much, Billy. I don't know if there's any questions from any of the audience members. I'll just wait a little moment, see if I can pick anything up. Okay. I'm thinking no questions. Shall I? We've enabled the question and answer option at the center of your screen. So if you do have a question, that's where you should, click and place it. I'll give it another minute or two.
Sure. Maybe I'll want to give another minute. Did you get a question yet?
No, I did not.
Maybe I'll throw a question out to the audience, and just to buy a bit of time here, and see if any views on increasing the collaboration across the country. Sometimes it pains me when I come from New Brunswick, and now I've been living in Alberta for so long, and any people that want to talk about partnerships between different provinces. I'll do that as I sip my Tim Hortons.
And while we ponder that question, there is a question now from the audience as well that I'll give it a second in case people want to chime in.
Yeah.
Well, while they're thinking about that, why don't I ask you the question that came up from the audience? What changes do you see additive making in your industry over the next 5 years?
Sure. Yeah, I would say probably just to go with 2 or 3 applications. There's a long list. We've seen opportunity for high wear applications. So what happens in industry is things wear out too fast, and then they have to go in, and it's an expensive change out, and they have to shut down production of the facility. So right now, one of the things we're tackling is high wear, and this is going to be an issue as we electrify the world. We're going to see increased mining operations, and mining is a high wear kind of environment. The other areas is more with freedom of geometry, is more efficient process devices. It could be a burner that is lower NOx or higher, more efficient in a boiler. It could be a piece of processing equipment that improves your yield, improves your productivity. There's a long list. Filters as well. Filters with a longer life, better efficiency. So the list is kind of growing. I would say if you go broader energy industry, I'm very excited about the potential for additive to change nuclear industry. So we've joined Camina, which is a nuclear consortium to look at additive how manufacturing can advance nuclear faster. So I would say that those are some of the main areas.
Okay, thank you, Billy. There's another question. How do you feel about AI in advanced additive manufacturing?
Yeah. Well, the role, I don't know, I guess there's a way of looking at AI and how do you make the shop floor more efficient and use AI for that. I think my view is more from an energy transition point of view is how can you how can you print smart parts? So one of the things that we're doing in collaboration with this NGen program is making more intelligent parts. So if you make the part intelligent, you're getting more data. And if you're getting more data, you can apply more intelligence to it. So I think one of the biggest impacts is really getting more sensors in more places so that we're measuring things in real time and optimizing operations.
Okay, thank you. Another question. What fundamental skills do you think are necessary for jobs in this field?
Well, I think first is you want to have the willingness to use your hands and be hands-on, and also then use your cerebral skills as well. So probably the skill to switch and to realize that you're not always in a desk job. Uh, so if you have a chance to help your family building a deck in the backyard or whatnot, like I grew up in an environment where I like to build things, and I think try to build something. And even if you're like, well, I'm not as good as the next person, I would encourage everyone to work on their hands-on skills.
Thank you. There's a question here. I'm just going to read the one that came up next for me.
Yeah.
Are you aware of applications of additive in carbon capture and storage? And I'm missing the bottom of this. Sorry, give me a moment.
Yeah,
Carbon
I saw one.
capture and storage media for catalysts, membranes, etc.
Okay. Well, additive plays a really neat role because of how fine of a geometry you can create. So just recently we created a flow battery with a customer, an energy storage device that would compete with Elon Musk's kind of energy storage. And we ended up 3D printing some of the membranes, and because the surface area is higher. So I would say absolutely. And around carbon capture and storage in particular, I know a lot of carbon capture and storage technologies right now are more amine based. So you use amines to take the CO2 out of the gas stream. There are also new applications that I'm not as 100% aware of that where I think these membranes can drive some positive change. But if anybody on the call knows more about those, maybe there's an opportunity there to work together.
Thank you. What is your experience with generative design, and how do you see it applicable in energy sector?
Yeah, I mean, when you look at the energy sector, you have upstream and downstream, and then you have the end user. So upstream is where you take the resource out of the ground. Downstream is where you refine the products for consumption, and transportation is where we consume the fuel, and that we're the point source of emission. I feel it's at the biggest opportunity is in the last category. Like generative design, typically right now, and maybe there are different opportunities for generative design, but right now it's been really focused on lightweighting. And if you can take a kilogram off of a commercial aircraft, you take a large amount of money off of the life cycle of the aircraft, and you drastically reduce its GHG emissions. So I see it more helping at that end of the spectrum. Within the energy sector proper, there are probably some use cases, but I would say they're limited, unless generative design is taking some leaps and bounds in other areas of complex flow geometries that could bring some change.
Thank you. Another question, what do you think about recyclability of additive manufacturing parts to be reused after reaching end of life? What are the target manufacturing systems for the recycled material?
Yeah, that will be a challenge, obviously, especially with composites. If we do additive with composites, the recyclability of those materials is a tough nut to crack. They do last longer, so the life cycle is generally better, which I think will overall, more reusing or just extending the life of that. I do think that Canada needs more facilities where plastics are recycled into potential feedstocks for things like additive manufacturing or other forms of manufacturing. So too much of this is kind of ending up in the oceans and other parts. So I don't know a ton about recycling of plastics, although there's some team members that would know more about it. And I could, feel free to reach out to me and I can connect you with them.
Thank you. What isn't additive manufacturing good at, and how would you like to see those resources placed instead?
Well, I think sometimes we get a little infatuated with additive because it's new and shiny, and there's a tendency to say, well, let's just 3D print it. And often we're talking to customers and we're saying, well, it's more practical to do this, and it's actually less energy intensive to say make 1,000 of these with injection molding. And I think it's a lot of it is people culturally being aware and not just printing for the sake of printing. I would say, right now, I would say it's not good at really large parts. As you get bigger parts, you have to get into deposition machines and the layer thicknesses are higher. So that's a real big challenge. And in the energy sector, the parts are big. They're very big. So I think we're not good at large parts yet, and that'll be a real challenge that I think that we need to see here to really make the change.
Thanks, Billy. Someone's typing in another question here, so I'm going to just give it a minute.
Okay. I never got anybody to jump in on the collaboration idea, but hey, that's okay.
How is the energy use intensity calculated across the product development life cycle of additive manufactured components versus traditional manufacturing?
Yeah. Well, I don't think this is calculated enough. And I think when you look at mass production using additive, you'll probably see in a lot of cases where it's actually more energy intensive. But the real value proposition for additive is you're making a part that goes into service in an industry. It could be cement, energy, mining, and it lasts longer, or it's more efficient, or it's better. So the real carrot to chase with additive is at the end use. So understanding these industries and understanding what reduces their carbon footprint is where you want to start your conversation. Then you want to look at how additive can reduce the energy intensity at that end user. Additive itself, the production methods, the manufacturing method, there's going to be some change that'll have to happen if we're going to start doing things at really large scale with additive. We talk about 3D printing furniture and stuff like that. Well, looking at the carbon footprint of that versus making it by traditional methods, this is going to be a real challenge for the additive manufacturing industry. I think there's people working on this though.
Again, someone's typing in the chat, so I will just, this is a longer question. Oh, on the collaboration side. So here you go, Billy.
All right.
I would be happy to discuss training opportunities on the design tools such as Autodesk Inventor, Fusion 360, generative design, and see how we can work on better and more efficient usage of the design tools for different manufacturing methods.
That's awesome. Yeah, we use all those tools, and no, there's definitely an opportunity there. So we should have a conversation. Ali, please reach out to me. I don't know. Yeah, I guess my answer to that question is yes.
Okay, waiting on the next question. Oh, Ali says, thanks, Billy. I'll give it a second, and if there are any other questions. I think that might be it.
All right.
So thank you very much, Billy. Really enjoyed this. And before we send everyone off to their next sessions, I just want to share a few housekeeping details. The 3D in Action Conference Committee has worked really hard to ensure that this virtual experience provides you with a comprehensive overview of additive manufacturing, and we certainly hope the conference experience runs smoothly. But if you do have any technology hiccups, please private message Andrea Johnson. She's noted as the event host in our virtual platform, and you can also email her at ideaworks@mohawkcollege.ca. So that's IdeaWorks, all one word, at mohawkcollege.ca. And she's also asked me to remind you to use Chrome as your browser. Now, most of our sessions will be recorded and will be posted online within the next 24 to 36 hours, and we will keep them online and the platform live for the next 6 months. So please enjoy the conference, and I look forward to connecting with you throughout the day. And thanks, Billy.